Good morning. So today we are going to present the poster on title Spatio-Statistical Model to Predict Crime Locations based on past crime events and UAV based monitoring of predicted surveillance route. This paper is prepared by Dr. Chauhan, Pranav Pandya, that is me, and Chansi Shah. We are associated with Birla Vishavakarma Mahavidyalaya Engineering College. Our paper ID is 21027 UASG 2021. So without any delay, let's get started. Introduction. Crime, as we know, is a stigma to the society. Crime is heterogeneously distributed and occurs at the most vulnerable places. Crime occurs under poor surveillance due to lack of safety, lack of public protection, and results in damage to public property or human life, creating a chaos in that particular area. Finding the probability of occurrence of crimes within such vulnerabilities will help crime units deploy certain countermeasures to reduce crime rate. Predicting the crime locations could help law enforcement agencies to counter it with appropriate approaches such as enforcing more number of police personnel, creating a borderline, creating a conflict-free region and blocking the region. So in the following research, a spatio-statistical model was developed for probability-based crime prediction using past data and location intelligence technology. Methodology. As we know, crime is a man-made disaster, but it originates when the criminal finds a social vulnerability such as human carelessness, inadequacy in taking precautions like walking in dark alleys alone at night, or lack of personal safety, carrying valuables in unsafe areas, parking vehicles in unregulated regions, etc. These regions, which were vulnerable, were clustered together, and the distance between individual crime occurrences within Vadodara city and individual police stations in the neighborhoods were correlated and evaluated. Later, the spatial distances between zonal geographical centers and crime spots were converted into geographical coordinate system to calculate their latitudinal and longitudinal extents of crime zones in each taluka. For carrying out the crime occurrence statistics, we have collected crime data. At first, we have organized the crime based on weekly count, and as shown in figure 1, we have seen that week number 36, 43, 24, 16 and week number 2 were outliers, and they were a little bit different because the overall occurrence of crime was much higher in these weeks. We have observed that during the month of August, September and October, the crime rate was skyrocketing. There was a literally large number of crime occurring in this state, and using this, police officers can be cautious during this particular months. The crime data was segregated seasonally. Now these seasons were calculated based on Indian Meteorological Department, which follows 4 seasons, which is winter, summer, monsoon and post-monsoon. And we have observed that during the monsoon season, the crime rate was highest. Because of that, police officers can be much more cautious during this season and be extremely alert to be able to fight the crime. Then next, the data used. So since crime is dependent on geographical factors, location-based crime data was collected. Data collection included the origin, place of the crime, date of crime, time of crime, number of people involved, and the type of crime according to Indian Penal Code. Crime data intelligence. Now this was a map which we prepared in the initial stages as we observed that Vadodara is gearing towards becoming a smart city, and yet it has observed continual growth in crime rate. This is an alarming situation. So based on that, we have represented the crime occurrences spatially in the map shown in figure 4. So crime occurrences in Vadodara city were clustered together to observe any hidden trend for vulnerabilities present in different regions. For clustering the crime occurrences into different IPC categories, so we can see that certain regions and certain locations have observed multiple types of crimes And these multitudinal crime zones are very difficult areas and they are critical to police surveillance because these regions indicate that those particular areas are vulnerable to not just one, not just two, but many different types of crimes. The next, crime category prediction. So after categorizing the crime data and visualizing it in the interpolated raster which was created using inverse distance weighted method, we have generated the following map which is represented in figure 7. As the label indicates, figure 7 represents the prediction of different crime categories and their occurrence in Vadodara city. So using this map, police officers and authorities can allocate resources to be able to handle predicted categories of crime accordingly. So the following map indicated the possibility of occurrence of crime of specified categories in the specified regions. Then next, we have UAV utilization in fighting crime. So as the research was solely focused on UAV method to handle crime, so UAVs were mounted with thermal vision cameras and they can be deployed in the particular location with highest probability crime zones at the highest probable time. So using both the temporal data as well as the spatial data, certain route was plotted which has been shown in figure 8, which represents the particular route that connects the highest number of crimes, spatially which were the hotspot regions, along with the time of occurrence of crime. So using this route, police officers can deploy UAVs which have thermal vision cameras and they can monitor the regions passively while sitting in their headquarters. Thank you.